Okay, multiplying and dividing rational expressions. We're going to be doing the exact things we did yesterday in simplifying. It's just going to be, there's going to be more stuff, right? Because we're going to have a multiply in there. But the whole idea is you're going to factor everything you see. You are then going to state restrictions based on the factored form of the denominator, right? Because we know that the denominator cannot be 0 because you're not allowed to divide by 0, right? So, let's start with just some really simple stuff. So, like if I'm doing 5/9 times 3/25, now amazingly enough, both of those are rational expressions, right? Although we are more likely to classify them as fractions, right? But that's fraction, right? It's fraction times a fraction. So you know how to do this, right? I mean, you can do this multiple ways. There are multiple ways. Here's one way that you would probably never do, right? You're never going to do this. And you can say, well, all right, so let's just write that. I mean, what does it mean when I multiply fractions? You multiply together the numerator and the denominator, right? So you would do that. You might just write it as 15 times 25 less than 250, 225. You might just write it as 15 over 225, right? But you know, we don't really want to go there because that's kind of making it a little more complicated. We want to make it simpler. So we could say, all right, well, the 5 and the 3, I mean, there's nothing you can do with 5 and 3, right? I mean, you can't factor a 5. But 9, well, that could be written as 3 times 3. And why would I do that? Because then I'm going to have 3's, top and bottom can cancel them, right? What can I do with the 25 then? 5 times 5. I draw lousy 5s. Goes back to elementary school, because you're supposed to do them like this, right? And that just seemed a waste of time to me, so I didn't try that. Anyways, so now what do? Well, we say, okay, 3, 3. Now remember, when you're canceling, you put a 1. Okay, and then a 5, and a 5, and 1. So what's left up top? 1. What's left on the bottom? 15. Okay? No, you're not really going to do that, right? Nobody, you've never done these. I've never done that. We've done stuff like this before, and I've never done it that way. So you could say, well, you know, what I would do is do this. Try and do this correctly. And then, all right, well, let's see. 5 goes into that 3 times and goes into that 45 times. Oh, but then 3 goes into that. And kind of eventually end up with 1 over 15, right? Or you might do this. This is more likely, right? Hey, the 5 there, right? And then you get 1 over 15. Anybody would do it that way? Would anybody do that? Yeah, so I think that's a lot of us would just do it that way, right? It's just sort of canceling in place, right? So we know that any term in the numerator can be divided into or can cancel with any term in the denominator, right? And any term in the denominator. So it doesn't matter whether it's, you know, this numerator here or this here, any term in the denominator, right? Because we're going sort of across there. All right, so let's make them look more like rational expressions. It would look like this: 3a cubed over 2b squared, 10b cubed. Okay, so there are multiple ways to do this. But the first thing we should say is there's restrictions, right? What can't A be? To do it on purpose with the A and B, what can't A be? What can't B be? Okay. So there are restrictions, right? Anytime there's a variable in the denominator, there will be a restriction. And you should be aware of that restriction. We won't always ask you to explicitly state them. You may want to, like just every time you do it, I'm just going to write down the restriction. It becomes important when you're solving equations that you know the restrictions, because sometimes you solve the equation, oh, wait, it can't be that value, right? Even though I actually have an equation that's solved and it said B is 0. And you got to look back up there and say, can't be 0. Okay, so there's no solution, right? So it's like the squirrel question. You show it, and then you reject it, right? Look, here's the solution, but it's negative, so we're not going to do this, right? It's extraneous. Okay, so what could you do? You could just multiply it out, right? So 3 times 10 is 30, a cubed, b cubed, and 2 times 9 is 18, and we got a squared, b squared. So you just multiply it straight out. And then we could do what we just did in the previous one. We could say, well, what's 30? I mean, 30 is lots of things, right? It's 1 times 30 is 2 times 15, but so let's say, what's the greatest common factor of 30 and 18? 6. So let's write 30 as 5 times 6. 5 times 6. So what's 18 going to be written as? 3 times 6, right? So the idea is we're going to have that common factor that's going to cancel, right? So the whole idea is common factor cancel. What's the greatest common factor of a squared and a cubed? A squared. So how are we going to write a cubed? Well, we're going to write it as a squared times a. What's the greatest common factor of b cubed? And really just use the same, no, that's, wow, this is different. Okay, what's the greatest common factor of b cubed and b squared? I write that down right? That's just, okay, so it's b squared, right? So we're going to write this as b squared times b. And we're going to write this, so down here, what are we going to write? Well, we're just going to write a squared and b squared. And now we can cancel, right? So the idea is we've got it in a factored form. It's a special factored form, right? We didn't factor 30 as 3 times 10. We said, what's the greatest common factor, right? Because we can cancel these things. And we can cancel the a squareds, and we can cancel the b squared. So what are we left with? We got a 5 times 1 times 1 times a times 1 times b. So we'll call that 5ab. And we've got a 3 times 1 times 1 times 1, which is 3. Okay. Now, what are we likely to do? I can say, okay, 3 goes into 3 once and into 9 3 times. 2 goes into 2 once and into this 5 times. The a squared is going to take this down to an a. The b squared is going to take this down to a b. And we're left with 1a 5b, which is 5ab. And we're left with 1 times 3. So you could do that, right? Only danger with doing that is that sometimes you miss stuff, right? Because there's a lot of crossed off stuff going on. So you could do it here. You could just say, well, okay, let's just deal with this. So, okay, 6 goes into that 3 times and into that 5 times. The a squared takes that down to an a. The b squared takes that down to a b. We got 5ab over 3. Okay, so multiple ways to simplify these guys. Let's put the green away. You can cancel in place, you can multiply it out and then cancel, right? You can do it on your calculator too, right? Just go 30 divided by 18, math, enter, and it'll give you 5 over 3. Okay, so if you want to know, you know, what does 30 over 18 cancel to, right? Okay, 30 divided by 18, math, enter. 5 over 3, okay, cool, right? And then just cross off the 30 and the 18, right? 5 and a 3. But that's kind of junior high stuff anyways, right? This is the real stuff. So here's the real stuff. X squared plus x. It's not that you won't see the other stuff. You might see like one of them. This is what you're really going to see. Well, sort of. This one's just kind of, this is an easy, like an intro. So what's step 1? Factor everything. Okay, so I'm going to put an equal sign here. I'm going to put this. I'm going to write down, okay, because I know that these guys are binomials, right? I'm going to throw brackets around those just because I can. Bless you. Okay, so if I were a betting man, what's one of these guys going to be? I don't even know. I'm not even looking at this, right? If I'm a betting man, one of these guys is going to be an x minus 3, right? Because it's going to cancel. So I'm going to say, all right, x minus 3. And if I'm a betting man, then what's one of these guys going to be? going to be an x minus 2, so that's going to cancel. Right? There's real factoring and fake factoring, right? Real factoring is just looking at that and factoring it. Fake factoring is looking at that and saying, okay, so this will be an x plus 5. And now what do I have to do? I need to FOIL this out and check it, right? X squared minus 3 is plus 2x minus 15. Yeah, and then to get a minus 6, it's going to need a plus 3. So x squared minus 2 is plus, yeah. Okay, so it does factor, right? So you can use what's in the question to help you factor, right? Because we are going to bet that there's going to be some cancellation going on. But we hedge our bet, right? So we check these. When we do factor it, we multiply it out, make sure that it actually is the factored form. What's the next step? You state restrictions. Yeah, restrictions. What can't x be? Negative 5, positive 3, and positive 2. Okay, so where do we look? Denominators, right? I don't care about here, although it doesn't matter because negative 3 is, that's already taking, thing. I don't care about this, right? I'm not going to put negative 3 down as restriction. I don't care if this is 0, so what? What's 0 divided by anything? 0. What's anything divided by 0? Undefined. That's what we care about, right? We can't divide by 0. We can divide into 0. Okay, now what? And what are we left with? X plus 3 over x plus 5. With the proviso that x cannot equal negative 5, 2, or 3. And explicitly, the only one of those that expression, that x can't be negative 5, right? I mean, you can put an x is 3 into that simplified expression. You can put an x equals 2 in a simplified expression. But remember, in the original expression, and that's what matters, in the original, you cannot put in a value of 2 or 3. So this is not equivalent to this if you make x equal to 2, right? This is undefined. This is 5 over 7. Right, so that's a big thing we got to keep in mind, right? And then eventually what you'll start doing is looking at graphs of this and saying, oh, that's why I can't make x2. Okay, questions? All right, so if it's there, factor it. Then state the non-permissible values. Division. So division just adds one more step. Okay, so if I have you dividing by a fraction, what are you going to do? Kiss and slip, right? So multiply by the reciprocal. What I learned, it was like invert and multiply, but for you guys, like kiss and flip. So kiss means change the divide into a times, right? That's the X symbol, as in. So before we do anything else, right, I'm not going to factor anything. I'm going to change the division to multiply. Okay. Oh, that's right. We could start writing it on the board. We're going to start taking that. So your first step, if you see division, you change it to multiply. You don't do anything else, right? Don't get ahead of yourself. Probably try and do too many things at once, and then things go bad. All right, now that it's a multiply, it's as if this were the question, right? So that's the original question, but that's the question. So now what do we do with this? Factor everything. Now, they're all reasonably easy to factor, right? I mean, I'd start with the bottom left, because that's the easiest thing to factor. Then I'd figure, well, one of these is going to be in x minus 6. Right. Anyway, so okay, you factor all 4. I don't care how you do it. It's like time for you to factor. So top left, check. Top right, Check. Bottom, yeah. Okay, is that good? Does that agree with yours? If not, you're wrong, fix it. No. Okay, now what? What's the next step? Restrictions. Yes, remember, restrictions. Okay, what are the restrictions? X cannot equal 0. Okay, what else? 6. Okay, so where are you looking for these restrictions? Denominators. Okay, I'm going to point to something. Tell me if it's is this a denominator?
No.
Is this a denominator? Is this a denominator?
Yes.
Is this a denominator?
No.
It is here. Right? That's a denominator. Now it's a numerator. But in the original expression, now it doesn't matter in a sense because the 6 is taken care of down here, but it will matter in future ones. So you're looking at things which are denominators, right? That's a denominator. That's a denominator. That's still a denominator. That was a denominator. That is a denominator. So it's only this guy that gets left out, right? We don't care, up or left, who cares, right? But everything else in a division, everything else, right? Because this is a denominator. So its values cannot evaluate to 0, right? Otherwise you're trying to divide by undefined. That doesn't work, right? It's like trying to divide by 0. You can't do that. Can't divide by undefined either. So in a division, you're going to be looking in 3 places for your restrictions, right? So here, here, and here. Okay, now, what's the next step? Now, I mean, I could have written this as x minus 6 quantity squared and then just crossed off the squared. Okay, that would work too. Sometimes it's nice just to write it out. Then I'm just crossing the whole thing off, and now we're going, oh, there's a little squared, and I got to cross off the little squared. Okay, anything else cancel? So what are we left with? Got an x minus 5 and a 1 and a 1 and an x minus 6. And I got an x and a 1 and an x plus 5. So this is equivalent to this for all values of x, except for 0, 6, negative 4, negative 5. Okay. Now, you could try that, right? You could stick like a 1 in for x and evaluate this, and stick a 1 in for x and evaluate that, and they should be the same. I'm not going to, but you could. Or you put a 2 in or whatever, right? Any value of x except for what? You can't use 0. You can't use 6. You can't use negative 4. You can't use negative 5. Any other value of x, this and this are the same. And this is the simplified form, right? No common factors left, right? Can't cross that x off with one of those. Don't try that. So division, first step, change it to multiply, factor, restrictions, but hey, it was a divide, so restrictions I gotta look up here as well. Cancel, state the solution. Okay, one more, right? So I want to keep this short. So. Okay. Right, that's no worse than 1/4 divided by 3/8. Right, I mean you do it the exact same way. So what's your first step? What's the first thing you do? Kiss and flip. Change it to a multiply, right? You're not going to do anything else. You're not going to factor anything. You're just going to say, all right, I'm just going to rewrite it. So you throw a little equal sign down, say, well, this is the same as, right? That's what the equal sign is saying. The line I'm writing now is equivalent to the line above. Okay, so 9s squared. Over. Times, okay, and just make sure you actually do flip it. Okay, step 1, complete. Next step. Now what? So now this is our new problem. Remember, that's the original. So we got to remember that this was a denominator. So we need to look here for which are all going to be very ugly non-permissible values, right? They'll have s's and t's. Okay, what's the next step? Okay, so of those 4, which one would be the easiest to start with? So use your mad factoring skills. Let's say, hey, that one there, that's and so that'll factor easy, right? I mean, they're all pretty easy to factor. Where are we going to start? Okay, this could take longer than half an hour, so take half an hour. That's dependent on you. You need to pick one and then say why. So upper left, lower left, upper right, lower right. I'll name them for you so you can then say, we'll start with the because. The lower right. Upper left. Why the upper left? The upper left is the square of a binomial, right? How do I know? The first term is a square, 9s squared, right? The last term is a square, and it's positive. So I'm saying it's going to be 3s plus 5t squared. Now you look at that and say, hey, you're right. Or say, I don't see that. Now you might want to write it like this. Okay. So here's the deal. I recognize it as the square of a binomial. How? Well, the first term is a square. Right, so it has a square root. What's the square root of 9s squared? 3s. What's the square root of 25t squared? What happens when you multiply 3s times 5t and then double it? You get 30st. That's how I know that it's the square of a binomial. Okay. Now, being as it's a simplifying question and all of that, there's probably another 3s plus 5t. Could that be down here? You can say no, because there's no way you can multiply 3s by something and you get 25s squared. Okay, so wait, let's build a little template here, right? Okay, so what's the bet? Where is there another 3s plus 5t? Bottom right. Okay, so if, that's a funny looking 3. If there is a 3, and there's no guarantee, right? This is simply if, then how do I get 12s squared? What goes here? Okay, how do I get minus 25t squared? Now you check that and say, wow, it actually, or no it doesn't, right? There's no guarantee. All right, what do we got? We got 12 minus 15 plus 20 is plus 5. Minus 15. Okay. Wow. Look, it actually is, right? So I call that factoring without factoring, right? We didn't factor this. You factor this, it's going to take you a while, right? I don't care how you do it. It's going to take a while. Guess and check. It's kind of ugly, right? Like it could be a 1 and a 12, a 2 and a 6, a 3 and a 4. Turns out to be a 3 and a 4. But there's a lot of ways to get, there's not so many ways to get this, either 1 and 25 or 5 and 5. But either way, I give you this cold, you're factoring this, we can agree. You know, the average time in the class is going to be a few minutes to factor it. How long did we take doing this? Yeah, you know, 15 seconds, right? Whatever. Okay. This one, well, once you recognized it, it wasn't that bad to factor. All right, what's the bet now? Where is there going to be a 4s minus 5t somewhere? Well, if there is, it's not there. So I'm going to say, all right, maybe there's a 4s minus 5t. Okay, is it possible? Yeah, because I can get a 20 from the 4. Now, there's no guarantee this is true, right? It's just simply saying, maybe. So, if I'm going to get a 20s squared, what has to go up here? 5s. If I'm going to get a minus 30t squared, or sorry, plus 30t, then minus 6t, right? Okay, so you should check that and let me know. I don't even know. Yeah. No, my notes are very poor on this. I just have the actual question. I don't have the answer. Okay, so that works. What do we got? 20 minus 25 minus 24 is minus 49. Holy smokes. All right, now what? Wow, if this whole thing canceled, then what else could there be and where could it be? There could be a 5s minus 6t down here, right? Remember, there's no guarantee, but it's possible. This is why we use a pencil when we do math, okay? Because maybe we're wrong. Okay, how do I get a 25s squared? How do I get a minus 6t squared? I'm going to go with plus, because I got a minus already, right? All right, so what do we end up with? 25s squared plus 5 minus 30 is minus 20. Holy smokes, look at that. We're not going to do restrictions, but if we did, where would we look? Everywhere but. Yeah, so if I'm doing restrictions, I'm not interested in it. Now, as it turns out, that is going to end up being a restriction because this is the same as that, and there's two of these guys here. Okay. I mean, the restrictions are 5s minus 6t cannot equal 0. 5s plus t cannot equal 0. We already did that one. This cannot equal 0. We already did that one. And this cannot equal 0. And, all right? But, you know, they're not restrictions we can actually say, hey, s can't be 5, right? It's like, s can't be 5 if t is this, okay? So don't worry about it, right? We're not worrying about it this time. Now what do we do? So we take the big red pen of crossing out stuff, and we start crossing out stuff. That doesn't cross out, these guys do. So that's all 1, and what do we left with? So 3s plus 5t and then various restrictions. Yeah, like 5s minus 6t cannot equal 0, etc. Okay, we would never ask you for the restrictions on, you know, unless it was like just a really simple one, and you just say 5s minus 6t can't be 0. Don't solve it from there. I mean, you could, because you could write, so 5s can't be 6t, and s can't be 6/5 t. Right, but then there's a lot of numbers it can't be. All right, so what's the idea, right? The idea is whatever we're given to begin with, we change it to a multiply, unless it is, and then we leave it. So if it's a multiply, we leave it. If it's a divide, we change it to a multiply. We then factor everything, and then what do? We then check our factoring, right? Because if you factored wrong, then from that point on, in the long and soon-to-be very painful process, because nothing's going to cancel, right? If you factor wrong, stuff's not going to cancel. That's one way you know you factored wrong. It's like, hey, nothing cancels here. Maybe I made a mistake. So factor, oh, sorry. If it's a divide, turn it into multiply. Multiply, leave it. Factor everything. Check your factorizations. Make sure they are correct. State your restrictions, right? State, it's not determined, right? You're just writing that. Here are the restrictions. If it's a divide, remember, there were 3 expressions in the denominator. There currently are 2 that are obviously in the denominator, but there's another one that was in the denominator. It's at under 30 minutes, 13 seconds, 12, 11, 10, stop counting. state the restrictions, and then cancel. And